Welcome back. Today we are going to start set theorem, and in front of us we have a question that reads, given that the universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 have sets A and B, such that set A is even numbers and set B is multiple of 3. So determine question 1 is A, question 2 is B, question 3 is A intersection B, question 4 is A union B, question 5 is A intersection B all complement, question 6 is A union B all complement, question 7 is A complement union B, question 8 is A union B complement, question 9 is A complement union B complement, question 10 is A intersection B complement, question 11 is A complement intersection B, and finally question 12 is A complement intersection B complement. So solution: the first thing that we have to understand is we are given a universal set, okay? And inside that universal set, we have set A, which is made up of even numbers. So what are even numbers? Even numbers are numbers that are divisible by 2. So it will be 2, 4, 6, 8, 10, 12, 14, 16, right? Okay, we're going to stop at 16 because the set has 16 as its final number. That is set A. Moving on to determine set B. It says set B is multiples of 3. When we talk about multiples of a number, that is you starting with that number, then you obtain the product of that given number, okay? Like 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, okay? 3 times 6 is 18, but we are going to stop at 15. The reason being, this set has maximum number of 16, okay? So this will be set B. I want you to first know the difference between factors of and multiples of a number. So if I say a factor of, let's say 30, here I am trying to determine numbers that I'm talking about you taking 30 as the given number and then dividing it by a number such that you will not have a remainder. So for example, factors of 30, if I say 30 divided by 1, I will have 30 without a remainder, right? So 30 divided by 2, you will have 15. So there is no remainder. 30 divided by 3 is 10, okay? 30 divided by 4 is 30 divisible by 4 without a remainder. The answer is no, okay? So that is not a factor of 30, but is 5 a factor of 30? Yes, so because 30 divided by 5 is 6. Okay? 30 divided by 6 is 5 times. Okay? So 6 is also a factor of 30. Alright? 30 divided by 7. So 30, you will have a remainder. It means 7 is not a factor of 30. 30 divided by 8, you will also have a remainder. 30 divided by 9, you will still have a remainder. 30 divided by 10 is 3. Okay? 30 divided by 11 is going to give you a remainder. So 11 is not a factor of 30. 30 divided by 12, you'll still have a remainder. 30 divided by 13 is not exact because you will have a remainder. But 30 divided by 15 is possible, and 30 divided by 30. So, which means the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30 itself. Okay? 1, 2, 3, 5, 6, 10, 15, and 30. Okay? So whenever we say a factor, think about division. Okay? So that given number, if you divide it by a number, if you do not have a remainder, then the numbers that you have will be the factors of that given number. But whenever we say multiple, always let product come to your mind. Okay? Multiplication. For example, if I say multiples of 3 will be 3, 6, 9, 12, 15, 18, and so on. Why? Because you are multiplying the 3 with successive integers. Okay, so like 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. So this is the difference between a multiple and a factor. A factor of a number is numbers that are divisible by the given number. Okay? The given number here is 30. So the numbers that are divisible by it are going to be the factors of that number, that is 30. But when we say the multiple of, here you are multiplying that number with successive integers. Like if we say multiple of 3, start with 3. If we say multiple of 5, will be 5, then 10, then 15, then 20, then 25, and so on. Okay? Multiple of 6 will be 6, 12, 18, right? And so on. So I hope that point is clear. All right? So to quickly give the answers, we said that for set A, it will be even number, so that is 2, 4, 6, 8, 10, 12, 14, and 16. And for set B is what? Multiples of 3. So multiples of 3 will be 3, 6, 9, 12, 15. Okay? So the next thing that you do is you try to see if there are common numbers between the sets. We have 6 and we have 12. So which means these two sets will intersect, okay? Even if the question doesn't ask you to draw a Venn diagram, it is advisable to do that first before answering anything. So let me first try to obtain the Venn diagram. Okay, so this is the Venn diagram. Okay, and for the Venn diagram, you always have to indicate the universal U. Okay, we have two sets and there are common members between the two sets, so there will be a point of overlap. So let this be set A and this be set B. Going back to our sets, for set A, we have 2, 4, 6, 8, 10, 12, 14, and 16. And for set B, we have 3, 6, 9, 12, and 15. So the common members are 6 and 12. That is what we need to write here. This circle is for set A, and this circle is for set B. So after writing the intersection, what you need to do is you have to write the remaining. So the remaining will be, for set A is 2, then 4, 6 is there, then 8, then 10, 12, so 14 and 16. So we make a quick control: 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, and 16. So we have indicated the members of set A. Now let's try to write the members of set B. Is 3, 6, we have it already, 9, 12, we have it already, and 15. Okay, so let's just try to make a quick control: 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. So what are the remainder? That is, we know that the set starts from 1 to 16. So it means there are numbers that are not in A and B. We have to write that outside. Okay, they are part of the universal. So that is, we have 1, 2 is here, 3 is here, 4 is here, but 5 is missing, so we have to write 5. 6 is there. Is 7 there? No, so we have to indicate 7 outside. Is 8 there? Yes. 9 is there. 10 is there. 11 is not there. We have 12. Is 13 there? No, so we have to write 13. We have 14 there, 15, 16. So this is the Venn diagram. All right. Members of A, members of B, members that are not in A and B. Okay, so there are terms that we need to understand very well before we can be able to answer the question. When we talk about intersection, that is N, we're talking about members that are common in both sets. Okay, so that is intersection. For this set, if I say A intersection B, I mean members that are found in A and B. They are 6 and 12. Okay, these are the members that are found both in A and B, 6 and 12. When we talk about union, that is U, we are talking about combination. Okay, so that is, you are going to combine the sets. Okay, combination of sets. So if I say A union B, I mean that you combine members of A and B. Okay, then the last thing is called the complement. The word that I want you to understand for complement here is an exclusion. Okay, exclusion of whatever they tell you, but you have to indicate anything that is outside apart from that exclusion. So these are the three things that we have to understand. Now let's answer the questions one by one. For the answer of question 1, it says members of A. So what are the members of A? Those are the members that we have here. Okay, we write them down again. 2, 4, 6, 8, 10, 12, 14, and 16. Question 2 asks us to give members of B. Members of B are 3, 6, 9, 12, and 15. Okay, let's go back to the questions. Question 3, A intersection B. Question 3 is asking us to find A intersection B. What is that? Meaning members that are found in A and B. A intersection B is 6 and 12. So let's write that. A intersection B, we have 6 and 12. Moving on to the fourth question, it asks us to find A union B. The fourth question is A union B, meaning we have to unite set A and set B. That is the members that you have here. So if we should unite A and B, we start from the lower number, that is going to be 2, then we have 3, then we have 4, then we have 6, then we have 8, then we have 9, then we have 10, then we have 12, then we have 14, then you have 15, and 16. That is A union B, meaning unite set A and B. So what is the fifth question? Is A intersection B all complement? A intersection B all complement. What that means is exclude A intersection B. That is it. So meaning that for A intersection B, we are only going to exclude this part, but we're going to write anything that is within the universal. So it means we're going to write members of A here, that is these numbers, and the members of B and the members that we have outside. But we are not going to include the intersection. So complement means an exclusion. So we're going to exclude A intersection B. And if you look at it from here, from the third question, A intersection B is 6 and 12. So if we complement that, if we exclude that, what are we going to have? We're going to have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, and 16. That is what A intersection B all complement means. Meaning, first find A intersection B, then exclude that. When you exclude that, whatever is inside the universal, you have to write it except them. Okay? So, moving on to the sixth question is A union B all complement. The sixth question is A union B all complement. What that means is exclude the members of A union B. What does that mean? So, which part is representing A union B? It is this part. Okay, so if you exclude the union, whatever is remaining, that is going to be A union B all complement. So it means they want you to find the members that are outside A union B. So look at it. If this is A union B, what is then remaining if at all you exclude this? That's what that means. So A union B all complement means we're going to have 1, 5, 7, 11, and 13. That is A union B all complement. So identify the members of A union B. If you exclude them, whatever is remaining inside the set is what you're going to write. Okay, that is what is A union B all complement. So what is question 7? Question 7 is A complement union B. Okay, what that means is find the members of A complement, then find the members of B, and then unite them. Union means unite. So what is A complement? First, let's find A complement. A complement means members that are not found in A, but are found in the rest of the universal set. So A complement will be 1, 3, 5, 7, 9, 11, 13, and 15. Okay, members that are not found in A. Okay, A complement means members that are not found in A but are found in the other set and the entire universal set. If you look at it very well, A complement will be if you exclude this. So what you're going to have? You're going to have 1, 3, 5, 7, 9, 11, 13, and 15. Then what are the members of B? Members of B are what? 3, 6, 9, 12, and 15. So if they say unite these two, that is A complement union B, just try to write whatever you have there. So it's 1, we have 3, so there is no need of writing it 2 times. We have 3 in both of them. Okay, so 1, 3, 5, 6, 7, we have 9 in both of them, so just write it once. 11, 12, 13, and 15. This is what is A complement union B. First find members of A complement, then write down members of B. Since union means to join, then try to join the two. So that is A complement union B. Let's try to find the answer for question 8. Question 8 is A union B complement. Okay, A union B complement. So we're going to break this down. First, let's find the members of A. Members of A are 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14, and 16. Then let's find B complement, that is members that are not found in B. So if you know B as this, B complement will be numbers that are not including this. Okay, so what is B complement? B complement is 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16. Okay, if we go back to the set, B complement will be if you exclude the members of B. So we'll have 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, and 16. Okay, that is B complement, meaning members not found in B. So let's go and see if we have the answers right. B complement, we already have B here. So if you exclude these numbers, what do you have? Starting from the lower number, 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, and 16. Very correct. So if you have them, you can now answer the question. It says you unite them. So A union B complement will be 1, 2, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, and 16. Moving on to question 9. Let's try to see what question 9 is asking us. Question 9 is asking us to find A complement union B complement. Okay? A complement union B complement. A complement union B complement. So it means find A complement, then find B complement, and then you unite them. What is A complement? Members not found in A, but are found in the universal set. So A complement will be sets that are here in set B and set that is outside. So that is going to be 1, 3, 5, 7, 9, 11, 13, and 15. A complement. A complement, we already know members of A, which are these. So if you exclude these numbers, what will you have? You'll have 1, you'll have 3, you'll have 5, you'll have 7, you'll have 9, you'll have 11, you'll have 13, you'll have 15, right? Yes. So what is B complement? That is members that are not found in B. We've already said that B complement is this. So let me just try to write that down. 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, and 16. So union means we join them. So A complement union B complement will be 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, and 16. So if you analyze the answers here properly, you realize that only number 6 and number 12 are missing. So number 6 and number 12, if you go back to the set, what we have as the intersection. So what does this mean? It simply means that we have complemented them, right? We have excluded them. So in other words, we can say that A complement union B complement is also the same as or is also equal to A intersection B all complement. That is question 9. Okay. So what is question 10? Let's go and find out. Question 10 is A intersection B complement. A intersection B complement. Okay. A intersection B complement. That is what we are trying to find as question 10. So what are we going to do? Let's try to first list the members of A. The members of A are 2, 4, 6, 8, 10, 12, 14, and 16. Then we list the members of B complement. What are the members of B complement? We have 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, and 16. So intersection means members that are common in both of them. So we'll have 8, we'll have 4, we'll have 14, we'll have 16. Do we have another? We'll have 10. What else? We'll have 2. These are the ones that I can find. Okay? So intersection means that are common in them. Okay? So what do we have? So A intersection B complement is, starting from the lower number, 2, 4, we have 8, we have 10, we have 14, and 16. All right. Then we move on to the 11th question. What is the 11th question? It says A complement intersection B. A complement intersection B. A complement intersection B. First, let's try to find members of A complement. What are the members of A complement? We have that answer as here, if you can look at it. So A complement is 1, 3, 5, 7, 9, 11, 13, and 15. So what are the members of B? Members of B are 3, 6, 9, 12, and 15. 3, 6, 9, 12, and 15. So intersection means members that are common in this. Do we have that? Let's try to identify them. We have 3, we have 9, and we have 15. So therefore, A complement intersection B is 3, 9, and 15. And finally, the final question is A complement intersection B complement. A complement intersection B complement. What do? We'll find A complement first. We have that answer previously, which is 1, 3, 5, 7, 9, 11, 13, and 15. Members of B complement is 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, and 16. So intersection means members that are common, right? So what are common in A complement and B complement? 1 is there, 5 is there, 7 is there, 11 is there, 13 is there, and that is it. So answering the question, A complement intersection B complement will be 1, 5, 7, 11, and 13. And that answers the question. All right. Does the answer that we have here, 1, 5, 7, 11, and 13, look similar to a specific region in our Venn diagram? Let's go back to the Venn diagram and analyze it. So if you can see, these 1, 5, 7, 11, and 13 are the numbers that we have that are outside of A union B. So, which means these are the values that you have in A union B all complement. Okay? Do we have a question of that A union B all complement? Is the sixth question. So let's analyze that. A union B all complement. What do we have for that? Question 6. A union B all complement is 1, 5, 7, 11, and 13. So what can we infer to this? We can say that A complement intersection B complement is equal to A union B all complement. Okay? Thank you very much for watching this video. Please subscribe to the channel, like, and share the video.